Mr. Ainsworth here, and we're going to be looking at piecewise functions, how to graph them, how to find the domain, the range, and determine if it is a continuous function or not. And so for this example, we have two functions. We can see we have x squared minus 2x minus 3 for when x is less than or equal to 3. And we have 2 times the absolute value of x minus 5 minus 4 when x is greater than 3. So really I have a parabola as the first function and an absolute value as the second function. And I'm going to keep that in mind. Now the next thing I'm going to do is I'm going to also kind of look at what my domain restriction is. What's my boundary? And it looks like for both of those there, it is x is less than or equal to 3, x is greater than 3. It looks like 3 is the boundary. So what I'm going to do is I'm going to draw a dashed line at x equals 3. That is my boundary line. My open closed circles have to touch that line. Both graphs are going to start or stop at that line. So that at least gives me a general idea. Now I'm going to keep that concept of a general idea to help me figure out my graphs. And so the first thing that I have is I have a parabola. And I know a parabola is U-shaped. And so I do know I'm going to have a graph that looks like this in some way, shape, or form. And I know the other one's an absolute value. Now, I didn't say it, but I do know they're both positive if I look at it, so they're both opening up. So I have pieces of these two graphs. Well, the parabola says x is less than or equal to 3. And so what I'm going to do is I'm going to remove the right-hand side. I want x is less than, so I'm going to remove the right-hand side of that parabola. And so if I do that, I can see I have this. Now, if I keep in mind the inequality, x is less than or equal to 3, that means this is going to be a closed circle. If I have the absolute value, it says x is greater than 3, which means I want to keep the right-hand side of that graph. So in some way, I'm going to have a right piece of an absolute value graph. And let me remove the left-hand side. Now this says x is greater than 3. So that means I have an open circle. So those are my two shapes. Now, I don't know if I have the full V shape shown on the absolute value or the full U-shaped curve on the quadratic, but I do that just so I can see the general idea. Now notice, it's going to look like something like this, or like this, or like this. In some way, shape, or form, this is what my final answer is going to look like, which is nice to know before I start the problem. So let me just go ahead and put it like this, and we'll just see what happens as we do it. But I have an idea visually of what I'm working towards, which is really good. So now I'm going to put in my functions into my calculator. So I personally, because they're more complicated, a quadratic and an absolute value, I'm going to go ahead and type them in the calculator and let the calculator spit out the table for me. But I'm going to be very careful when doing that, because for the x's, I want less than or equal to 3 only for my parabola. So x squared minus 2x minus 3. Now remember, the boundary is where we're going to start. So I'm going to start at 3. But I want numbers less than 3. So I'll just pick 2, 1, 0, -1, dot, dot, dot. So even though I'm putting dot, 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 I'm going to still use that curve and follow the direction there. So if I look at it, at 3, I am at 0. At 2, I'm at -3, then -4, then -3, then 0. That's what I'm going to get from my table. So let's just go ahead and graph it. We did say, remember, this is going to be a closed circle. We talked about that already. So at 3, 0, I'm going to put a closed circle. At 2, -3, we keep going. Then at 1, -4. Then at 0, -3. And then at -1, 0. I could see that curve happening. The next one I would have would be actually be -2, 5 if I wanted to plot that. And you can see the parabola forming itself. So I'm going to sketch it. Look at that. That's what we had right there. Perfect. We had that parabola shape. We kept it. Now the next table is based off of x is greater than 3. But we do need to be careful. We put that boundary line there for a reason. My graphs have to touch that boundary line. So I'm still going to use 3 as my starting point. Whatever number they give me here is the number both tables start at, no matter what. But I want greater than 3. So I'm going to do 4, 5, 6, dot, dot, dot. Now if I plug in 3, I have 3 minus 5 is -2. The absolute value of -2 is 2. 2 times 2 is 4. 4 minus 4 is 0. I get 0. Perfect. If I plug in 4, I get -2. If I plug in 5, I get -4. I get -2. And then I have my ... It's going to keep going. This is pretty interesting. If I plug in 3, I get 0. So I have an open circle going on top of that closed circle. That's interesting. So then what do we have next? We have 4, -2, 5, -4, and then it goes up to 6, -2. If I plot the next one, I'd have 7, 0. I probably have 8, 2, and you can see that V shape forming. So there's my graph. Which if you look at it, that is exactly what I have here. All that changed was where does it lie vertically on that boundary line, and it happens to lie right here. So I do have that general shape that I knew I was going to have. So kind of analyze first. It's going to make you know what you're going towards and faster in the long run. Now if I were to follow this and think about continuous, what that means is, can I draw from one side of the graph, can I follow it from left to right without having to lift up my pen? And the answer is yes, I can. The reason why is because at this unique value, at that whole closed and open circle, there is no vertical gap there. I can actually have the open circle on top of that closed circle, which means it is continuous. If I were to shift that open circle up here, then it would not be continuous because I'd have a jump in the graph. So this one is continuous. So I have a continuous graph. The next part we're looking at is the idea of domain and the idea of range. Domain are the x values. This graph does go left and right forever. And even though it has this weird boundary up, doesn't look like it can be 3, we do have a closed circle there. 3 is allowed because of this or equal to. So my domain is all real numbers, or as I prefer to do, interval notation, -infinity to infinity. Now your range is based off the y values. I have to look vertically on what's going on. And the lowest part of that graph is down there. It looks like the lowest part is right here at -4. That's the lowest the graph goes. And all the other curves will follow along and keep going up forever. So that means my y value is greater than or equal to -4, or as I prefer to do, -4 to infinity. And since 4 is included, it's in brackets. So this is piecewise functions. And if you were to take a look at it, the idea is to kind of know what you're dealing with before you start the problem. The rest of it's just tables, which calculator can help you out with. You have x squared minus 2x minus 3, a parabola, and it's telling you keep the left side. So that's what I drew right here. You have 2 times the absolute value of x minus 5 minus 4, but it's telling you keep the right side. That's what I drew there. Before I even started the problem, I knew what was going to happen. I couldn't tell if it was going to be continuous or not, but at least I knew my shape of the graphs. Hopefully this helped you understand piecewise functions just a little bit more.